Okay, so after seeing the theory and examples of Gaussian elimination, let's talk about Gaussian elimination in real life. Okay? So, computers use Gaussian elimination. And why is this? This is because Gaussian elimination is by far the fastest way to solve a problem if you want to reduce the number of operations that you are doing. Okay? So let me do a table in which I write first column will be the number of variables in the system of equations. Second column will be the number of operations required to solve the system using Gaussian elimination. And the third column will be the number of operations required to solve the system by calculating the inverse. Okay, so let's do it. Okay, so for a 10 by 10 system of equations, you would require 333 operations to do Gaussian elimination, approximately, and you would require 39 million operations to calculate the inverse for a 10 by 10 matrix. So this is to calculate the inverse using the Laplace expansion method. Remember how long that method was. This is for 10 variables. What if you have 1,000 variables, which would be normal in a computational problem? So using Gaussian elimination, you would require around 333 million operations. But using the calculation of the inverse, you would require approximately 4 times 10 to the 2,570 operations. So basically that's impossible to calculate in the lifetime of the universe or whatever comparison you want to make. So it's impossible to calculate the inverse when the number of variables is very high. Okay, if you want actual numbers, so for n number of variables, Gaussian elimination requires approximately n cubed divided by 3, while calculating the inverse requires n plus 1 factorial. So that's why any computer, whenever you ask a computer to solve a system of equations, they will do Gaussian elimination. Okay, and they will use the pivots to create the zeros and so on. Okay, and actually I kind of challenge you, if you want, you are learning Python in the computational side of the module, so why not practice some Python using arrays to do Gaussian elimination on any matrix? Yeah. Actually, in Python, there is already an implemented version of Gaussian elimination. Yes, so this is how you would do it. So to solve the problem Ax equals b, you can specify A as an array, and this is our matrix A. Yeah. Then you specify b as a vector, also an array. This is array 9, 8. And then you use the function linear algebra solve, and you provide A and b, and you get x. Okay, so that's how you would do it in a computer. Thank you very much. So actually, one small detail, I said it's impossible to calculate the inverse for big matrices. Of course, that's only true if you use the Laplace expansion method, which is very, very long. But actually, using Gaussian elimination, you can also calculate the inverse. It's just that I thought that was too much for first year maths, so don't worry about it. But if you're interested, look up Gaussian elimination, but you keep adding zeros not only below the pivots, but also above the pivots. And this is called reduced row echelon form. And it provides a way of calculating the inverse of a matrix that is very fast. And it's the way that computers will calculate the inverse of a matrix if you ask them to. Thank you very much.